Hey, welcome to the Science Masterclass. I'm Mr. Salagaras. Today we're going to learn about types of chemical reactions. Okay, make sure you stay tuned for this one because there's lots of important pieces of information that can be a little bit tricky to understand. So you might need to go back at the end of this and watch it again. Let's get started, shall we? Okay, most chemical reactions can be placed into the following categories based on what they produce. Okay, these are the 5 categories we're going to look at today: combination, decomposition, single displacement, double displacement, and combustion reactions. What the heck are they? Let's have a look. In a combination reaction, we've got 2 or more reactants form one product, usually a compound. Okay, the reaction of sodium and chlorine, for example, forms sodium chloride. You've got two, where you've got an element and then you've got a molecule that come together or interact to produce. We know it produces by the arrow symbol there, the compound of sodium chloride. So you no longer got 2 separate components, they form into one, so the combination of 2 into 1 forms that compound. So that's how I always remember a combination reaction, is where you've got 2 components combining to form one. Okay, so a decomposition reaction is basically the opposite. It's where you're breaking down that one component into 2. Okay. So a compound is broken down into something simpler like elements or compounds or molecules. An example of this is where I've got hydrogen and oxygen gas being decomposed from H2O, that compound of water. Let's look at the formula here. You've got H2O is the compound, produces in a decomposition reaction H2, which is the molecule for hydrogen gas, and you've also got oxygen gas, which is O2. That's where it's decomposed from one component into 2 separate components through that reaction there. Those 2 are probably the simplest ones for you to get your head around. Remember, go back and look at that again. Let's look at our next one, a single displacement, where or one element displaces or kicks out another element from a compound. Let's have a look at what this looks like. This is a bit tricky, but you can get it. For example, if you put a piece of zinc metal into copper sulfate solution, the zinc displaces the copper, so kicks it out, as shown in this equation. Let's break it down into its chunks. We've got an element of zinc here at the start, reacts with copper sulfate here, which is a compound of CuSO4, which produces, okay, so here's the kicking out part here. We've got zinc sulfate now, the compound, and now you've got the element of copper by itself. So let's have a look at where things are kicked out and how this displacement works. So at the start, you notice that you got zinc reacting with copper sulfate. In the reaction, what happens is that that zinc at the start kicks out or displaces the copper in the compound, leaving the copper to sit by itself as an element in the product there. So it's important for you to understand when I'm talking about reactants and products. So if you don't get that, go back to that previous video that we looked at. Remember that the reactants come before the arrow, products come after it. That'll help you to understand what I'm talking about. Okay, so single displacement, where one of the elements is kicked out and displaces it during that reaction. Okay, double displacement is where you got a 2 of the chemical species are displaced. So similar to that double displacement, single displacement, but you've got 2 of them are now displaced. Let's have a look at this here. I've got barium chloride at the start here as my first compound. When it reacts with silver nitrate here, it produces silver chloride and barium nitrate. So the metals, all they do is they exchange, they swap between each other in the products here. So I have barium changes place with the chlorine, with the silver to become silver chloride and barium nitrate. Remember at the start it was barium chloride and silver nitrate. All the metals do is swap, the non-metals stay the same. That's what a double displacement is. That's probably the easier of the 2 to understand. Okay, combustion reactions. This is the reaction of a substance with oxygen in the air. Sometimes the word burning is used instead of combustion. The substances that react with oxygen is said to be oxidized. The result is a product called an oxide. This is an example of an exothermic reaction, one that gives out heat energy. So Carbon and oxygen produce carbon dioxide. Iron and oxygen, when they react, cause iron oxide. So you can tell that it's a combustion reaction when you've got something reacting with oxygen to produce a oxide or a dioxide or something with IDE in the product there. Okay, here are some general patterns that you can follow with writing these type of reactions, that combination, the decomposition, single displacement, and double displacement. So the letters A and B represent the individual components, or even the C, the individual components. Have a look at this and see if you can see those patterns in some of those examples we used previously. Okay, let's just talk about endothermic and exothermic reactions. Endothermic are ones that take in heat from the surrounding area and cause a decrease in temperature, whereas exothermic are ones that give off heat, causing an increase in the temperature surrounding the area. Hey, heaps of information in that. Go back, watch it again, make sure that you're really confident with those patterns, practice it, get your heads around it, ask questions, and make sure you like this video, subscribe to my channel, and make sure you watch it again. Thanks for watching.